Threshold Pharmaceuticals Metabolic Targeting is a unique and powerful new approach to cancer therapy. Metabolic targeting is widely applicable to more than 90% of cancers and holds promise to prolong remissions and prevent relapse of solid cancers, enhance the potency of current therapies, and increase the specific delivery of drugs to the site of disease, limiting side effects. Unlike current cancer treatments, which are narrow in their application and work only against fast-growing tumor cells, metabolic targeting exploits fundamental differences between normal and diseased tissues to attack the entire tumor, including the slow-growing but malignant core. Metabolic targeting works in a manner similar to PET scanning, a powerful cancer diagnostic tool. PET works because cancerous cells consume more glucose than healthy cells and can be specifically labeled by dyeing them with a glucose mimic. Threshold's metabolic targeting takes the logical next step, which is to selectively target tumor cells for destruction based on increased glucose uptake. Tumors, unlike normal tissues and organs, are highly disorganized. Rapidly dividing cells near the tumor's surface and blood vessels, where oxygen is abundant, are the targets of current anti-cancer therapies. But cells deeper inside the tumor lack access to oxygen and other nutrients. Cells in these hypoxic zones are slow-growing but resistant to current therapies. At the same time, they are prone to mutations that can make them highly aggressive. Threshold's compounds target both the rapidly dividing cells and those in hypoxic zones, based on a shared characteristic that differentiates them from normal tissues: dramatically increased consumption of glucose. Like normal cells, rapidly dividing cancer cells produce energy through glycolysis and the citric acid cycle, but they must consume much more glucose to fuel their rapid growth. Meanwhile, cells in hypoxic zones must rely only on glycolysis, a less efficient process that requires large amounts of glucose but doesn't require oxygen. Threshold's investigational compounds take advantage of this increased glucose metabolism to deliver drugs selectively to tumors. For example, glufosinamide uses glucose as a decoy to fool tumors into ingesting a toxin. Because it mimics glucose, glufosinamide is consumed by tumor cells at a much higher rate than normal cells. But once inside the cell, the glucose falls off. A toxin is released that causes irreparable DNA damage, killing the tumor and reducing the chance for relapse. One of the major functions of the human prostate gland, the production of seminal fluid, requires the accumulation of zinc and secretion of extraordinarily high levels of citrate. This function is performed by glandular epithelial cells. These are the same cells that overgrow in BPH. As part of their normal function, prostate epithelial cells have metabolic requirements that make them unique from other cells in the body, a reliance on glycolysis to generate energy. TH070 works by inactivating hexokinase, the enzyme that catalyzes the first step in glycolysis. This turns off the cell's last remaining source of energy production and induces programmed cell death in the prostate epithelium, reversing BPH and improving symptoms without affecting surrounding tissue.